Entering the 21st century, from an American perspective, basic sanitation is universal. Porcelain toilets are made available for public use in restaurants, shops, and schools. Waste from these innovations flow directly into local wastewater treatment facilities and is broken down before being reintroduced to the environment. In a culture where such utilities are universal, it is difficult to imagine that raw sewage is a problem in other parts of the world. As clear recognition of this problem, one UN Millennium Development Goal is to have the number of people without access to basic sanitation by 2015. Access to wastewater treatment directly corresponds to socioeconomic class in developing nations. Slum dwellers often live among raw sewage, or find their water supplies are tainted. In the Kenyan slums of Ngundu and Marage, out of 31 wells tested for fecal matter, all were found to be contaminated. In rural areas, it is common for raw sewage to be used as fertilizer, as it is a cost-effective means of growing crops. Without treatment, this sewage rampantly spreads disease. Although the most common wastewater treatment systems of the United States imitate nature, as it sends water through a series of filters, such plants are multi-million-dollar endeavors. By returning to nature and observing its ability to break down waste, we may significantly reduce the complexity and cost of wastewater system designs. Natural wetlands may be mimicked by man-made lagoons, in which water settles into the bottom of the pool, where soil and rocks filter the particles and bacteria, breaking down the waste that was introduced to the system. The treated waste makes excellent fertilizer for plant life in the area and promotes a sustainable system. Our design, a floating drum digester, copies nature in its ability to break down waste. First, waste is introduced to the barrel and mixed thoroughly with equal amounts of water. A valved barrel is then placed upside down in a larger barrel. Natural bacteria break down the waste over a period of weeks and create methane gas, which is collected in the valved barrel. Upon completion of the digestion, methane may be released from the valve and can be used for cooking purposes. By mimicking nature's processes, we have significantly cut down the cost of our design and were able to build a single structure for the entire wastewater treatment process. Our wastewater system does not stand alone. As part of the Ecovillage creation, our design requires us to consider multiple other systems in the creative process. First, we must consider energy needs of the Ecovillage inhabitants. Our goal is to provide fuel for daily cooking through the digester. Next, we consider water and the need to obtain unfiltered water from a local stream to mix with the waste. In order to meet the needs of the Ecovillage inhabitants, we must obtain animal waste as an addition to human waste, which will come directly from the agricultural area. This design must then be integrated with the housing structure and made easily accessible to its inhabitants. Finally, the system must be reproducible, with the goal of making it easily replicable across the Kenyan nation. This is the job of the education team. Without the consideration of all of these systems, the present state of Kenyan wastewater treatment and the processes of nature, we would not be able to complete a successful wastewater system design.